Hello everyone, this is the last topic in the unit organic compounds containing nitrogen, and now this is a very important topic, and in this topic we'll be discussing diazonium salts. Now then, what are diazonium salts? The diazonium salts, they have the general formula R N2X minus. Now what R may be alkyl or aryl, and then here the focus is mostly on the aryl diazonium salts. Now, why aryl diazonium salts? I'll be discussing later. Now, aryl this is the general formula. Aryl, we have R. This is aryl. The aryl means is 6H5. Therefore, N2 AR. This R will be our aryl, and then N2 will be N2 is known as the diazo means 2 nitrogen, and plus means nium, diazonium, and X minus can be chlorine, bromine, or not only the halogens but it may be HSO4 minus and BF4 minus. Now this may be the X may be halogens or other anions. Now therefore the nomenclature here is aryl. Now if our compound is C6H5 and 2 plus Cl minus, then this will be named as benzene diazonium chloride. Benzene diazonium chloride, and another example, N2 plus HSO4 minus, then this will be named as benzene diazonium. This is our hydrogen sulfate. Hydrogen SO4 minus is known as sulfate. So this is the naming nomenclature of the diazonium salts. Now, alkyl diazonium salts are not preferred because they are not stable at room temperature. Now, why do we study the diazonium salts in the aryls? Now, aryl diazonium salts, they are stable for some time due to their resonating structures at low temperature. Now the temperature maintenance is also very important here because the aryl diazonium salts are stable only for some time due to resonance at low temperature. At low temperature, that is 273 to 278 Kelvin, they are stable sometime due to resonance. The aryl diazonium salts, this is our aryl diazonium salt. Now they are stable at room temperature, at low temperature for some time. Now the resonating structures here we can see here is now if this goes here, then this bond breaks, one pi bond breaks up and goes and adds up to nitrogen atom. The second resonating structure would be here we have a positive sign, double bond and minus and then plus. Now if this bond goes here, the third resonating structures would here, since this bond has gone here, a positive sign here, double bond and minus and then plus. Now if this bond breaks and goes and bonds up here, the third resonating here, a positive sign will appear here and negative and then plus. Now this goes here, and then therefore this pi bond breaks and goes up here, therefore will be getting back our starting material. Now here one thing to note that only the primary aryl can give diazonium salt. Only primary alkyl and aryl group can give diazonium salts, and alkyl diazonium salts are not stable. Therefore, we will be studying only aryl diazonium salts. Now, aryl diazonium salts are here. They are stable at low temperature for some time due to these resonating structures. Now, preparation. Prepare how are aryl, the benzene diazonium or the aryl diazonium salts prepared. Now, in this process is known as the diazonization process. In a process called the diazonization process, benzene diazonium chloride is prepared. Excuse me. Now, therefore, let us check. Now, in this reaction, primary amines react with freshly prepared nitrous acid to give our product, that is our benzene aryl diazonium salt. Therefore, now let's check our aniline. Aniline reacts with nitrous acid. Nitrous acid are prepared NaNO2, since it should be freshly prepared and in the solution. Therefore, NaNO2 and HCl should also be present in the solution to give this. At 273 to 278 Kelvin, we'll be getting C6H5 and 2 plus, and then Cl minus with the removal of NaCl and H2O. This is our benzene diazonium chloride, and this process is known as diazonium chloride. And however, due to its instability, the diazonium salt is not generally stored and is used immediately after its preparation. However, it should be noted that the diazonium salt is prepared only when the diazonium salt is needed, as it is unstable and cannot be stored. Now, our benzene diazonium chloride so obtained is a colorless crystalline solid. A colorless crystalline solid will be obtained. It is readily soluble in water and is also stable in cold water, but it reacts with water when warm. However, when the water is warm, it reacts with warm water, and it decomposes easily in its dry state. And the benzene diazonium fluoroborate, this is our fluoroborate, is water insoluble and are stable at room temperature. The other diazonium salts are all soluble in water, but however, benzene diazonium fluoroborate is water insoluble and stable at room temperature. And in the next video, I'll be discussing the chemical reactions of diazonium salts.